the like bases cancel out each other, and you're left with just the exponents equaling each other. And you solve from there. Same is true for log of the same base as well. But you got to know this, guys. It's log on both sides of the equation. Okay? Sometimes you have an equation that's going to have, like for the one over here, that log is only on the left side. There's nothing on the right. So you can't just say, oh, okay, let's go ahead and cancel out the log of a and set a of x equal to x. That does not work. It has to be the log with the same base on both sides. That's what cancels out. Then it goes on to show something really important, guys. Make sure we get very familiar with this. The natural log of e cancels out each other. It's 1. Okay? And so what we talked about before when we were talking about expanding and condensing, we said, okay, if there's an argument of a natural log or log function, the argument has an exponent. For example, what you see here. You see this argument here has an exponent. It's x. And so what happens is we can go ahead and take this x and move it to the front. Now it ends up being x times the natural log of e. And as we had talked about, this ends up being 1. So it's x times 1, which gives you x, and that's the reason why that works. You go to the other side. If you have an exponent raised to a log function of the same base. So you notice the base of the exponent and the base of the log function are the same. They cancel out. All you're left with is x. Vice versa. Log base of a, these two are the same here and here. So this all cancels out and you're left with x. And of course you've already saw on the left side, natural log of e. Well, if you say e is raised to a natural log power, those go away and you're left with x all by itself. Alright, so let's go ahead and use this information in order to solve. Well, on day 1, we talked about how you convert log functions to exponentials. Do you remember what we used in order to do that? We called it fishhook, right? Circle the base, get a line around the answer, and point it to the argument, a fishhook. So, 2 raised to the third power is equal to 1 minus 2x. So we solved this. What's 2 raised to the third power, guys? 8. There you go. After the 8's established, you can go and use simple algebra to solve the equation. You find out that x is equal to negative 7/2. Any questions about that? You're using the rule of converting log functions to exponentials to help you solve this equation. We could not have done it without converting it to exponentials, because the variable is in the argument of the log function, so you can't. The only option you have is to convert it out. That's the only way you can do it. All right, goes on to talk about something with expanding and condensing, which we've already kind of discussed before. It says here is the rules that you have. So if you have the two arguments being multiplied together, like m times n, well, what is it when I have exponentially? What is it that I do with, I don't want to do that. How can I rewrite that? 2 to the x plus y. So what happens is we have two arguments here, if you look back at the box, that are being multiplied. We can expand that by adding them together. So the log sub a, the log of a, plus log of n. You add those together. Or log of m and n. All right, so we go ahead now and let's use that. Let's condense and so forth and so on. Because this equation, guys, can go reverse. If you have two of the same log base functions, like we have in this example right here, you can put them together by going to the equation we just talked about in the box and going reverse. So if I have the two log functions with the same base being added together, I could actually put them together Is it log base 5? Okay. And actually, I end up just taking the two arguments and multiplying. All right? And so from here, again, it's set up to where your argument has the variable, which means we've got to do what, guys? Yes. Fish hook it out. 5 raised to the first power is equal to x plus 6, x plus 2. So, what's 5 to the first power? Careful. 5 to the first power. That means 5 multiplied times itself, none times except just once. It's not even multiplied itself, it's just 5 all by itself. So it's 5. What is x plus 6 times x plus 2? By now I figure you guys can start maybe doing some of the stuff in your head, because there you go. So what you do is, first two terms multiply gives you x squared. The next one is the two numbers combined. It's plus 6 and plus 2. Do you see that? Combine them together to give you 8x. And then the last one is the two numbers being multiplied. Plus 6 plus 2, it's being multiplied together gives you positive 12. So there you go. What do I do to solve this, guys? Why? It's quadratic. So we have to subtract 5. It has to be set equal to 0. So you end up with this. What is it? Okay. Are they both the same? Good job, Casey. Put you on the spot, didn't I? Oh, there you go. So here's the deal. What is the actual answer, though? We found the factors of it. We set them equal to 0. What's the answers we have here? -7 and -1. However, we are not done here. It's -7 or -1. But you got to remember this, guys. Give me the answer to x. Matter of fact, let's do this. Get your calculator, guys. Go grab a calculator from the room. Or if you have one with you, that's great. Get it out. Josh is a good guy. Let's grab for everyone. He said children would Alright guys, are you showing our calculators? Yes, you're going to be able to use your calculators on the test. So we'll go ahead and introduce you to a way how to put log into your calculator. So you go to, make sure, reset your calculator first, please. So second plus 712, long device. Similar shape. Alright, so second plus 712, make sure reset. Then what I want you to do is this. Alpha, window. Should give you a bunch of options here, and you should see something that says log base something. I think it's option 5. Yeah. Once you do that, it'll paste it to the window. Now you see log, and you see a little cursor under the subscript there, waiting for you to put it in. So go ahead, put in log base 2. Press the right arrow to go to the argument and put -4. And press enter. We got an error. Why is that? Because it's a negative. Why is that a problem? Could someone explain to me in English?
You can't square something with a negative.
You got to check to see if these both negative answers are going to work. So we go back into the problems themselves and plug them in and make sure we don't get any negative arguments. Well, let's go with negative 1. What's negative 1 plus 6? Positive 5. We're good. What's negative 1 plus 2? Positive 1. So that's great. Let's go over and try negative 7. What's negative 7 plus 6? Negative 1. Guess what? That's not going to work. Here's your answer. As soon as you plug in one of your solutions and you get a negative answer, stop. That answer won't work. It doesn't matter if it works in one and not in the other. I don't care. As long as if it doesn't work in one, it will not work at all. Okay? So cross that out. So the answer is x equals negative 1, and that's it. All right. On to the next one. So natural log of x equals the natural log of x minus 4 equals natural log of x plus 6. All right, so the first thing is we're going to try to get it where it's one natural log on both sides. So what you have to do is combine. Combine the two together. So natural log combines with the other natural log. And remember, if it's plus, that means you're going to multiply. So what do you notice has happened here? Is there one natural log function on both sides? And so what we have now is this. And we can solve this. I don't know why that looks like a B. All right. Getting closer to this. All right, so now how do we solve this again, guys? What do we have to do? Yep. All right, the old dreaded quadratic formula with 5 and 6. It gets lots of y'all's pretty easily, so be careful here, okay? 6 is tricky because it's two factors. Think about it. What are the two factors of 6? 2 and 3. If I add them, what do I get?
5.
What's the other factors of 6? What if I subtract them, what do I get? 5. 6 is the only number that does that, guys. You got to be careful. You got to realize at this moment, are we subtracting the factors or are we adding the factors? We are subtracting. So make sure you do that. All right, so if our factors is x minus 6 and x plus 1, what is our answers? 6 and negative 1. Go back, plug in real quick and make sure everything works. If I plug in 6 into the very first term, the natural log of x, I get natural log of 6. That's great. That's doable. Natural log of 6 minus 4, which is 2. That works. Natural log of 6 plus 6, that works too. 6 is okay. Negative 1. Natural log of negative 1, can't do it. There we go. All right, so moving on to, it says now solve by converting, then using a calculator. Well, how do we convert this, guys? Fish hook. Circle the base. Go around the answer. This time, since it's exponential, you have to point to the exponents. So, natural log base of, or log base 2 of 5 equals x, which is... There you go. 3 decimal places. Best practice. I know that because I just put it on the test, but you have to round to 3 decimal places. So there you go. 3.22. All right. I won't count off if you're 1 off. That's 1/1000th. I don't really. In stats, we don't round, we truncate, so I don't understand why we just do the same. All right. Class practice. Hey, that's for you guys. You're the class. I'm the teacher. Let me say teacher practice. So, guys, if you want to pair up with somebody, move somewhere else, whatever you want to do to work through this, go ahead and get it done. And I'll check on it in just a few minutes.